Okay, let's dive right into this explainer. I want you to picture a small, seemingly innocent blip on a retailer's checkout screen. Just a minor change in customer demand. It really shouldn't be a big deal, right? But in so many supply chains, that tiny shift triggers an absolute operational catastrophe across an entire global network. Today, we're going to follow our supply chain hero, Logi, as he tackles this exact crisis head-on. So, you might be wondering, why does this happen? Why on earth does a small change in customer demand create such a massive inventory crisis? Well, today we're going to look at why an unmanaged supply chain is just inherently unstable. We'll see how completely isolated decisions made by totally well-meaning managers, by the way, end up creating these massive, destructive ripple effects.
Think of a supply chain as essentially a giant row of dominoes. A single disruption at the very front of the line, at the retailer, knocks over everything behind it. You push one block, and that compounding reaction just gains huge momentum as it travels backward.
Okay, here is our quick roadmap for today's explainer. We're going to cover 1, a small demand ripple, 2, defining the bullwhip effect, 3, causes of demand distortion, 4, the damage to operations, 5, the collaborative solution CPFR, and 6, stabilizing the supply chain. Basically, we'll start with the symptom, diagnose the disease, and then provide a concrete cure.
Part 1. A small demand ripple, the journey upstream. Let's start by tracing a seemingly harmless customer order backwards through the network. Picture Logi standing inside a massive manufacturing factory. Step 1. The retailer feels a tiny demand ripple in the marketplace and adjusts their orders. Step 2. The wholesaler sees this and adjusts their own orders slightly higher, just to be safe. Step 3. The distributor overcorrects even more, anticipating a huge surge. By step 4, when this signal finally reaches Logi at the factory, the fluctuation is completely unrecognizable. Isolation and delayed information breed sheer panic at every single node. Which brings us to section 2, defining the bullwhip effect, also known as the Forrester effect. Enter the monster. Formally, the bullwhip effect is the phenomenon where minimal variability in customer demand is distorted and amplified, with increasing volatility as participants become more remote from the end customer. Simply put, the crucial point here is that the further away you are from the actual consumer, the more wildly your required safety stock and production levels swing. It literally transforms into a giant, volatile demand monster. Section 3. Causes of demand distortion. Why the whip cracks. So what exactly causes these highly trained trading partners to constantly second-guess each other and overcorrect like this? First up, we've got the human behavioral causes. When managers lack visibility into the whole chain, they get scared, rightfully so. They misperceive feedback because of time delays. If demand isn't met immediately, they hit the panic button. They start panic ordering. Add in the perceived risk that other players might fail, and you get a massive overreaction to backlogs. It's essentially shortage gaming, everyone trying to protect themselves, which ironically only feeds the beast. But hey, it's not just psychology, it's systemic too. Practices like order batching, where a company waits to place one massive order at the end of the month instead of steady, smaller orders, those create artificial spikes. Add in completely isolated forecasting models, price promotions that temporarily disrupt normal buying patterns, and just a general lack of coordination, you've essentially systemized the distortion. Section 4. The damage to operations, the cost of chaos. Let's take a look at the financial and operational wreckage left behind by all this amplification. The massive loss of revenue and efficiency is just undeniable here. The goal of any network is stable production, lower expenses, and great customer service, right? The bullwhip reality is a total mess. We see alternating waves of excess inventory just sitting idle, followed by sudden, incredibly painful stockouts. We get wasted capacity, frustrated workers, and significantly higher manufacturing costs. Moving on to part 5, the collaborative solution, CPFR, the antidote. Now that we've diagnosed the damage, how does Logi actually defeat this monster and synchronize the network? The ultimate solution is CPFR. That stands for Collaborative Planning, Forecasting, and Replenishment. This is a process where trading partners jointly plan key supply chain activities from raw materials all the way down to the final products. It's a framework specifically designed to force companies to look beyond their own four walls and mitigate those super expensive overreactions. Imagine Logi literally plugging cables in to connect the retailer and supplier dashboards into one unified data network. By sharing critical data, like real-time point of sale or POS data through electronic systems, partners eliminate the need to guess. They agree on joint demand assumptions, share promotional plans, and set rules for exception management. Real-time data just flows from the retailer straight to the distributor, supplier, and manufacturer, all simultaneously.
Look, the traditional supply chain relies on isolated algorithms and serial one-by-one communication. It's basically a giant game of telephone that ends in reactive panic. But a CPFR supply chain, the real value isn't in buying a more sophisticated, isolated algorithm for just one company. No, the magic is in replacing multiple, conflicting forecasts with one unified truth, one shared forecast, real-time visibility, proactive alignment.
And finally, Section 6, Stabilizing the Supply Chain, the New Flow. Let's walk through how this synchronized, data-driven network operates in practice.
This step-by-step process replaces fear and batching with disciplined, transparent alignment. First, you share data openly. Second, you collaboratively plan. Third, you forecast jointly, creating one shared demand signal. And finally, you replenish based on actual data, not panic. Under this system, Logi watches the bullwhip monster shrink. Those wild, thrashing waves flatten out into a smooth, stable demand wave based entirely on actual consumer pull.
Now, there is a core truth to remember here. As the saying goes, CPFR does not remove uncertainty. It reduces distortion by making supply chain partners plan from the same demand signal. This perfectly captures the essence of the solution. You can't predict the future perfectly. Actually, consumer demand will always have some natural variance. But you can stop amplifying the errors. You can stop feeding the monster.
And that brings us to our final takeaway. Share data. Plan together, forecast jointly, replenish with discipline. I'm going to leave you with this provocative final question to apply to your own operations. Are your supply chain partners truly sharing information, or are they just guessing? Because as we've seen today, the cost of guessing is simply way too high. Thank you so much for joining me for this explainer, and I really hope you feel empowered to go out there and tame the bullwhip effects in your own networks.